Hi, my name is Abhishek, and today I'll be giving you a presentation on graphene and its impact on our today's technology-driven world. What is graphene? Graphene is a new supersubstance that hosts an array of wonderful properties. It is the first resistance-free conductor known to man. It is incredibly light, while at the same time stiffer than diamond. For such a stiff substance, it is remarkably flexible, stretching up to 20 times its original size before breaking. It's a long honor list for a relatively new substance, which only marks its 10th birthday today. However, graphene has been shown to do this, and so much more in lab conditions. So a complex, new, exciting substance like this must have taken years of development, right? Especially today, when science is such a process-savvy and exact science. Let me take you back to early October 2004. Imagine yourself as a Russian physicist. One day, as you joke around, playing on your desk with a pencil, you accidentally rub it onto the table. Now a normal person would rub that out with an eraser. No, you being the physicist that you are, ask your colleague for a more ingenious solution. Hey, Kostya Novoselov, how would you solve this? Your colleague, obviously tired of your eccentricities, just turns around and says, I don't know, here, have some graphene. No, I'm joking. What he says turns around materials engineering in the first decade of the 21st century. He tells you to use Scotch tape, which surprisingly takes off some of the graphite off the pencil mark on the table. A few weeks of research, and you find out that you can actually take off manually each layer of graphite. Roughly 500 rolls of Scotch tape later, you succeed in isolating a single layer of graphene. Graphene is unique in the fact that it is a 2D crystal. As you can see here, it is made up of hexagonal blocks of carbon atoms. Each carbon atom is bonded to 3 other carbon atoms. And as you know, each carbon atom has 4 electrons, so the spare electrons exist in the gap between the hexagons. This allows graphene to be an excellent conductor of electricity, as no protons impede its progress, which happens in metals and semiconductors. The carbon bonds make it strong, and since all 4 electrons have a place to go, this material is stiffer than diamond. The fact that it is 1 atom thin makes it flexible, and and while it bends, it still retains all of its properties. Since it has a large amount of empty space between the atoms, it only absorbs 2.3% of light that is shone on it. The fact that this makes it transparent, and the fact that it conducts electricity well, means that it is good material for touchscreen glass in the smartphone industry. Another application of graphene is in the microprocessing industry. How many of you know Moore's law? Yeah, okay. Well, as these people know, Moore was a person that predicted that in order for the microprocessing industry to stay competitive, the size of the microprocessing chips had to halve in size, while the number of transistors that were inside it had to double roughly every 2 years. Well, graphene is a very strong contender to ensure that this rate of progress increases, because graphene makes sure that electricity is conducted at an atomic level. One downside of using graphene in transistor material is that it has no band gap. A band gap means that a certain amount of energy needs to be supplied by the current in order for the substance to start conducting electricity. This is because the 1 electron has to get delocalized. However, because graphene has inherently 1 free electron, there is no band gap. This makes it hard for it to be effectively used in transistors, as a band gap is required for binary computing. If a current is below the band gap, it registers as a value of 0, and if a current is above the band gap, it registers as a value of 1. This problem, however, can be solved by doping the graphene with a silicon atom. And another inherent property of silicon is that it has a band gap, which means it only starts conducting electricity after a certain current is applied to it. Using graphene for transistors is such an innovative idea because right now most of the computing industry depends on rare earth metals. 90% of these rare earth metals are manufactured and mined in China, where they use environmentally damaging but economically viable methods such as open earth mining. This destroys whole ecosystems, and at the current rate of extraction, rare earth metals are expected to run out in the next 40 years. Graphene is a bitter substance because the allotrope of carbon from which it is manufactured, graphite, is widely found throughout the earth, and it is less environmentally damaging to use. This benefits New Zealand as we can gain a foothold in this industry because we have a high amount of skilled engineers, and we also have a high amount of facilities that can use this technology. This would help us. This would help wean us off our normally strong industries right now, such as tourism and agriculture, which China is expecting to dominate in the next 30 to 40 years. Thanks for listening.